In part 2 of our discussion on cryptography attacks, we're going to be talking about a few attacks that are a little bit more advanced than simple brute force or dictionary attacks. One such attack is the attack on an algorithm or on a crypto system. Now, this requires pretty much an expert hacker who has in-depth knowledge about a particular algorithm and its known weaknesses, or about a crypto system and how it works and how it's implemented. Now, obviously, this kind of attack would take advantage of any known weaknesses in the algorithms or systems or their implementation. One example that we gave earlier is the example of WEP. Now, WEP uses the RC4 algorithm, and by itself, RC4 is not a bad algorithm. However, it's implemented very poorly in WEP, which makes it very easy to crack. Another attack that we'll talk about is the statistical attack. Now, if you've ever done these little cryptograms in the backs of magazines, then you probably already know what a statistical attack is. It basically analyzes the frequency of the most statistically common pieces of plain text. And what that means is, let's say you're doing one of these cryptograms and you know that E is the most common letter used in the American alphabet, for example. So you might look for all the letters that you think are E's. Also, you might look for T's and A's and O's and other of the most common letters. So statistically, those letters would have a higher frequency than others. So you would be able to pick those letters out and through context solve the other letters. So that's basically what a statistical attack is. Another common attack is the birthday attack. And the birthday attack is used to attack web encryption, and it attacks the hash value and the initialization vector. Now, this is based upon a mathematical problem called the birthday paradox. And what this means is, if you get a bunch of people in a room, what are the odds that any two of them will have the same birthday? Well, through math, you can figure out that at 23 people, there's a 50% likelihood that any two people will have the same birthday. And you might think, well, what does it take to increase those odds? Well, at 57 people, there's a 99% chance that any two of them will have the same birthday. So how do you boost that to 100%? You go to 367 people. Because keep in mind, there are only 366 possible days of the year, and I'm including leap years there. So out of all those possible days, you add one more person, you go 367, and the odds are 100% that at least two of those people will have the same birthday. So that kind of attack can be used and implemented against cryptography because there are only finite numbers of possibilities. So that's a birthday attack. There's also something called a meet-in-the-middle attack, and this basically is a technique, and again, it's a mathematical technique, and what it does is it tries to find a common value using both a piece of the ciphertext and a piece of plain text, and you put this through several different functions or block ciphers or other mathematical algorithms such that the forward mapping of the first function is the same as the backward mapping of the last function. And essentially you would meet in the middle. Now that's a very complex explanation for a cryptographic attack technique. And again, there's some math involved there, and I'm not going to go in depth on that. You don't need to know that for the exam. Another common attack that you're probably already aware of is the man-in-the-middle attack. And this is basically where an attacker controls a communication session between any two parties that are communicating if they have not been mutually authenticated. In other words, each party has not confirmed the identity of the other party. Maybe only one party has. We see that a lot in SSL. For example, when you're trying to buy something from Amazon.com or some other online merchant, the server is typically authenticated to the client because you want to make sure that you're giving your credit card information to the correct server, for example. But the server does not necessarily authenticate the client. You can be coming from anywhere. So in those situations where they're not mutually authenticated, an attacker could conceivably insert themselves in the communication session. Both the sender and the receiver may think they're talking to the correct party, but they're actually talking to the hacker. And typically this involves the interception and replay back and forth of cryptographic keys, like digital certificates, for example. Now there's some other attacks that we'll talk about as well. We already mentioned kind of a replay attack, and basically that involves the replay of intercepted credentials that could be passwords, session keys, authentication keys, and so forth. We also have the known and chosen attacks. We have a known plain text attack where the attacker has a piece of ciphertext. It's encrypted. and he knows the corresponding plain text. So they're able to use this to further extrapolate what another piece of plain text would look like if it were encrypted given the same algorithm. So that's a known plain text attack. We also have a chosen plain text where the attacker generates a piece of ciphertext that corresponds to a piece of plain text of their own choosing. So they choose the plain text and generate ciphertext according to what they have. And so then they can do comparisons and figure out how these would be generated given a piece of unknown plain text or unknown ciphertext. We also have a chosen ciphertext one, and the attacker in this case can derive the plain text corresponding to a specific piece of ciphertext of their own choosing. So they have several pieces of ciphertext, and the goal is to take the ciphertext and derive or figure out what the plain text is based upon that. And again, it may involve comparison. If they can generate ciphertext and derive the equivalent plain text, then they can see how the algorithm works possibly. And then they can do the same thing to another piece of ciphertext and generate plain text. So they're doing this to figure out exactly how the plain text is derived. And so the goal might be to get a particular piece of plain text or to work on a particular piece of ciphertext to get the unknown plain text. So there are several of these attacks, and usually I'll tell you they're pretty much automated attacks using more advanced tools. You typically don't sit down with a piece of paper and pencil and do this. So those are some more advanced cryptography attacks.